Hi everyone, I hope you're doing well, and this is the stochiometry this time, and this is very important as well as complex. So in this chapter we are going to cover these things: the mole and molecular weight, the very first thing, and then molecular formula and empirical formula, and after that we will discuss the balancing equations and amount of reactant and product, the limiting reagent, molecular formula and percent composition, and theoretical and percent yield as well. Okay, yes. So we are going to cover all these things in this chapter, and I will discuss all the topics in a very different way, very easy way, and very tricky way. Okay, so let's start the mole and molecular weight. So what is mole first of all? So 1 mole is equal to Avogadro unit, means 6.02322 into 10 to the power 23. This is called Avogadro number. Okay. In short, it is denoted by Na. So this is called 1 mole. Suppose I am saying 1 mole pen, which means 6.022 into 10 to the power 23 pens. Suppose I am saying 1 mole book, it means 6.022 into 10 to the power 23 books, like that. So what is mole? This is very important formula. Mole is equal to weight in gram divided by molecular weight. And what is a molecular weight? It is a sum of atomic weight of all the elements present in a compound. Suppose I am saying we have a CH4 molecule, and I am saying what is the molecular weight of this. So we know that it is composed of carbon 1 plus 4 times hydrogen. So carbon's atomic weight is 12 and 4 hydrogen is 1. So 4 plus 12, which is 16. So this is 16 gram. Okay, the molecular weight. Makes sense? So this is the formula for mole. Okay, now we have a question. It is talking about find out the number of carbon atom present in 24 gram carbon. So again, look at here, it is talking about number of carbon atom present in 24 gram carbon. So first of all, we have to find out mole. And what is mole? Mole is my weight upon, if you have just a carbon, so you can take its atomic weight. Okay, atomic weight of carbon. Clear? So what is weight? 24. What is molecular weight? Yeah, atomic weight of carbon 12. So this is 2 mole. How many mole? 2 mole. Clear? This is 2 mole of carbon. 2 mole of carbon. But it is talking about number of carbon atoms. So we all knew 1 mole is equal to 6.022 into 10 to the power 23 23 any unit. Suppose atom, so you can say atom. If it is a particle, then you can say 6.022 into 10 to the power 23 particle, anything. So but here we have 2 mole, so we can say number of carbon atom will be what? If 1 mole has 6.022, then 2 mole has 2 into 6.022 into 10 to the power 23 atom. This number is called Avogadro number. So we can say 2 Na atom. Makes sense? So this is the number of carbon atom present in 24 gram carbon. I have a question for you. I am saying find out the mole of 32 gram H2O. 32 gram H2O. Take your time and find out, please. Okay, look at here. We all knew mole is equal to what? Weight in gram divided by molecular weight. Okay, makes sense? So what is molecular weight? Sum of their atomic weights. So H2O means 2 hydrogen plus 1 oxygen. So oxygen is my 16 and hydrogen is 1. So 2 into 1. plus 16, which is 18 gram. So weight is 32 divided by 18. So this is my mole. To make this easy, we can use here 36 grams, supposed to be 36. The calculation will be easy for us. Give me 1 second. Suppose here I am saying 36 gram. So 36 divided by 18, which is 2. So we have 2 mole. Clear? Makes sense? Easy. Okay, now look at this question. Yeah, this one. So here we have to find out, we have 98 gram H2SO4 and their atomic weights are given. So first we have to find out the mole of H2SO4, then we have to find out the mole of sulfur atom, then we have to find out number of sulfur atom, and so on. So let's do one by one. So whenever you have given anything, so first find out the mole. And what is mole formula? Mole is equal to weight upon molecular weight. Weight upon molecular weight. Its weight is given, which is 98. And what is the molecular weight? Sum of atomic weights are given, so just calculate it. So we have H2SO4, which means 2 hydrogen plus 1 sulfur plus 4 times oxygen. So hydrogen into 1 plus sulfur is how much? 32 plus 16 into 4, which is overall 98. Clear? So here my molecular weight is 98, so mole we have just 1. So we got 1 mole H2SO4. Here we can say 1 mole. Now these are the very important one. Look at here. Look at the H2SO4 molecule. What does it mean? We got 1 mole H2SO4. So look at how we can analyze this. 1 mole H2SO4 means in 1 mole of H2SO4 we have 2 mole hydrogen. 2 mole hydrogen. 1 mole sulfur, 1 mole sulfur, and 4 moles oxygen, 4 moles oxygen. Clear? Makes sense? This is 1 mole. Makes sense? So it is talking about mole of sulfur atom. So sulfur is just 1 atom here and we have 1 mole. So you can say 1 mole sulfur atom we have. How many? 1 mole. Clear? Now number of sulfur atom. So it's quite simple. You have to just multiply with the Avogadro number. We got 1 mole sulfur atom and it is talking about number of sulfur atom. So mole into Avogadro number. So 1 into Avogadro number 6.022 into 10 to the power 23. Or even you can say 1 into Na. Mole of hydrogen atom. So look at here. We got 1 mole H2SO4 in which 2 hydrogen atom we have. Clear? So hydrogen is how much? 2 into 1. 2 into 1. Clear? So that will be 2 mole we got hydrogen. Next, mass of sulfur atom. This is very good. So first you have to find out mole of sulfur atom. So look at 1 mole H2SO4 has 1 sulfur atom. So 1 mole means 1 mole sulfur atom. And if you have mole of sulfur, then it's quite simple. Mole is equal to weight upon atomic weight or molecular weight. Because sulfur is atom, so we can use its atomic weight. Mole we have 1. Weight we have to find out, suppose X. And what is the atomic weight of sulfur? 32. So X value will be 32 gram. 32 gram. So it will be 32 gram. Next, mole of oxygen. So 1 mole H2SO4 contain 4 mole of oxygen. How many mole? 4 mole. Okay. So we can say it will form 4 mole of oxygen. 4 mole. Clear? And you can find out the mass of oxygen as well. Just write down the mole is equal to weight upon molecular weight. So weight is how much? we have to find out. Mole is given 4, divided by molecular weight is 16. Clear? So 16 multiply by 4. So this is all about the H2SO4 molecule. Okay, find out the mass of hydrogen atom present in 32 gram CH4. This is very good question. Mass of hydrogen atom present in 32 gram CH4. So first job is to find out its mole. So look at here, mole. Mole is equal to weight upon molecular weight. How much weight? 32. How much molecular weight? So look at here. Carbon is 12 and 4 into 1. So 16. Okay. So 32 divided by 16. How much? 2 mole. Clear? Now look at here. CH4 molecule. If you got suppose 1 mole CH4, what does it mean? What does it mean? In 1 mole of CH4, 1 mole carbon and 4 mole hydrogen. This is the way you can read it. In 1 mole of CH4, 1 mole is carbon, the number of carbon atom is 1 mole and number of hydrogen is 4. So 4 mole hydrogen. But here we have 2 mole and it is talking about hydrogen. Yes, hydrogen. So 1 mole has, look at here, 1 mole has 4 mole hydrogen. Then how many mole of hydrogen will form in 2 mole? So 2 mole has 8 mole hydrogen. 8 mole hydrogen. Because 1 mole has 4. So 2 mole means 4 into 2, which is 8. So now we have mole of hydrogen and it's quite simple to find out its mass, because mole is equal to weight upon molecular weight, and we have the mole. How much? 8. 8 is equal to weight we have to find out, and what its molecular weight? 1. Hydrogen is 1. So X value is what? 8 gram. X is equal to 8 gram. Clear? So X is equal to 8 gram means 8 gram hydrogen will be there. Clear? Similarly, you can find out its carbon as well. So 1 mole in CH4, 1 mole only carbon. So 2 mole of CH4 means 2 mole carbon. So let's suppose we have another question. Find out mass of carbon. Mass of carbon. So look at here. 1 mole CH4. Number of carbon is 1 mole. In 1 mole of CH4, 1 mole is carbon. Makes sense? We got total mole as 2. We got total mole of CH4 is 2 mole. 2 mole. So 1 mole has 1 carbon mole. So 2 mole means 2 carbon. 2 mole of carbon. 2 mole of carbon. And once you have a mole of carbon, then weight it quite simple. What? Mole is equal to weight upon molecular weight. Mole is 2. Weight is X. Molecular weight is 12. So 24 gram. Clear? 24 gram carbon will be here. Makes sense? We did this. Okay, now the next. There is another formula once you have an ideal gas. So look at here. Number of mole is equal to volume given upon molar volume. Because 1 mole of ideal gas occupy 22.4 liter volume at STP. STP means standard temperature and pressure. So what is molar volume? Molar volume always be equal to 22.4 liter. Okay. You have to put here 22.4. So number of mole is equal to volume given upon molar volume. So look at this question. It is talking about find out the volume occupied by 3 mole of CO2 at STP. So what is the formula? Number of mole is equal to volume given divided by molar volume. So molar volume is always 22.4. Number of mole is given 3. And volume we can find out. So 22.4. So answer will be what? V is equal to 22.4 into 3. Clear? Simple. Makes sense? How many mole of oxygen are present in 88 gram CO2? Quite simple. This is very, very simple. So look at here. So 88 gram of CO2 is given. So our first job is to find out the mole of CO2. Mole of CO2. Mole of CO2. And what is formula? Weight upon molecular weight. Weight is how much? Weight is how much? 88 gram. So 88 divided by. What is the molecular weight of CO2? So we know that carbon is 12, 16 into 2. How much? 32 plus 12. 44. Yes, this is 44. So which means 2 mole. How many mole? 2 mole. So look at here. 1 mole CO2. Oh, it is just, it is talking about oxygen. So look at 1 mole has 2 mole of oxygen. How many mole? 2 mole of oxygen. Again listen me. 1 mole has 2 mole of oxygen. So how many mole of oxygen in 2 mole? Easy, just multiply. 2 into 2, 4 mole. 2 into 2, 4 mole. The answer will be 4 mole. Simple. Make sense? If suppose I am talking about how many mole of carbon, how many mole of oxygen here? I am talking about how many mole of carbon. How many mole of carbon? Carbon. So look at here. Carbon is just 1 in number. So 1 mole has 1 mole carbon. So 2 mole has 2 mole carbon. Simple. Make sense? 1 mole has 1 mole carbon. 2 mole has 2 mole carbon. 3 mole has 3 mole carbon. Simple. So here we got 2 mole overall. So 1 mole has 1 carbon. So 2 mole has 2 carbon. Simple. 2 carbon. 2 mole of carbon. Then listen me, there are so many type of question can be asked from here. It can be talking about what is the mass of oxygen. Simple, mass of oxygen. So once you have a mole, you can easily find out its mass. Let's do it. I am talking about what is the mass of oxygen. Mass of oxygen. Oxygen, mass of oxygen. So we have mole of oxygen, 4 mole. Am I right? We have 4 mole of oxygen. So once you have a mole of oxygen, so mole is equal to weight upon molecular weight. Mole is 4, weight we have to find out. Molecular weight of oxygen is 16. So 16 4 ja 64. So 64 gram oxygen. Simple. Okay, now the next question. The molar volume of copper is 7.09 centimeter cube per mole. What are the density of copper in gram per centimeter cube? So what is density? Density is equal to mass upon volume. Volume means molar volume. Okay. So density it is talking about. Mass is how much? Its mass is 63.5 gram per mole. Divide by how much volume? 7.09 centimeter cube per mole. So mole cancel out. So answer will be 63.5 divided by 7.09 gram per centimeter cube. The unit will be gram per centimeter cube. You can see gram per centimeter cube, which is same unit. So answer will be here B. Simple. How many hydrogen atom are present in 0.001 mole of CH4? Look at here. This time mole is given. If mole is not given, weight is given, then my job is to find out its. I will generate a question. Just solve this one first. So we have 0.001 mole CH4. So you can see, suppose 1 mole CH4, it is talking about hydrogen. So in 1 mole of CH4, how many hydrogen atom? 4. So we can say mole-mole ratio. 1 mole CH4 has 4 mole hydrogen. 1 mole CH4 has 4 mole hydrogen. So how many hydrogen in 0.001 mole? Just multiply. So number of mole of hydrogen will be 4 into 0.0001, which means 4 into 10 to the power minus 3. Clear? That is my mole of hydrogen, mole. But it is talking about how many hydrogen atom. And I told you that whenever you have to find out number of particle, number of atom, number of ions, always multiply. I think I discussed the formula. Let me write this again. Look at here. Number of particle, number of atoms, ions is what? Just multiply mole with Avogadro number. Clear? So it is talking about number of hydrogen atom. It is talking about number of hydrogen atom. It is talking about number of hydrogen atom. So number of hydrogen atom means you have 4 mole of hydrogen. So number of atom is what? 4 into 10 to the power minus 3 into 6.022 into 10 to the power 23. How much? So 6 4 ja 4, 24, and 20 minus 3 is what? 20, 10 to the power 20. So 24 into 10 to the power 20, this is 2.4, so it's quite simple. So 2.4 into 10 to the power 21. Makes sense? We can write 24 into 10 to the power 20 is 2.4 as 10 to the power 21. So A will be the right choice. 53 gram sample of Na2CO3 and its atomic weight is given, and this is the molecular weight as well. This is molecular weight, which is overall, once you solve this, it will be 106. Clear? So let's find out first mole of Na2CO3, because weight is given and molecular weight is also given. So mole of Na2CO3. Okay, so how we can do this? Weight upon molecular weight. So weight is how much? Weight is 53. So write down 53. What is molecular weight? 106. Then it is 1 by 2. 1 by 2 means 0.5 mole. 0.5 mole. So simple thing is that how we can correlate. Look at here. 1 mole of Na2CO3. How can we read this? Look at here. 1 mole has 2 mole sodium. 1 mole of Na2CO3 has 1 mole carbon, and 1 mole of Na2CO3 have 3 mole oxygen. Clear? In terms of 1 mole. But we got 0.5 mole. So what it should be? For 0.5 mole, how many sodium? We can say 2 into 0.5, which means 1.0 mole of sodium. Clear? How much? 1 mole of sodium. Okay, 1 mole of sodium is not here. And Na2CO3 we got 0.5, but this is 1 mole of Na2CO3, so this is wrong. Second, this is about sodium. Now let's talk about carbon. So 1 mole of Na2CO3 has 1 mole carbon. So 0.5 mole has 0.5 mole carbon, because same number of atom carbon. So 0.5 mole carbon. Here 0.5 mole carbon. No, 1 mole carbon. Wrong. Let's talk about oxygen. So 1 mole oxygen has 3 mole oxygen. So how many mole of oxygen in 0.5? Just multiply. So look at here. 1 mole has 3 mole oxygen. So 0.5 mole have 0.5 into 3 mole oxygen. So once you multiply 0.5 into 3, it will be 1.5 mole oxygen. Clear? 1.5 mole oxygen is only option A. So this is quite simple thing, you know. Whenever you have any substance, just find out the ratio in terms of 1 mole, and then you have any number of particular amount, then you can multiply with those number. Look at here again. I said the question is talking about 53 gram sample of Na2CO3. So first job is to find out the number of mole. So mole is what? Weight upon molecular weight. So weight, okay, let me do this again. Look at here. Let me do this again. I said first job is to find out mole of Na2CO3. What is the formula? Weight upon molecular weight. Weight is 53 and molecular weight is 106. So this is 2 mole, 1 by 2, which is 0.5 mole. So this is my mole of Na2CO3, and mole of Na2CO3 is 1, so C is wrong. Clear? So once you have the mole, total mole, then you can analyze in this way. So we can say 1 mole of NO2CO3. Now look at 1 mole Na2CO3 has, in terms of 1 mole I am talking about, 1 mole has 2 mole sodium, and 1 mole carbon. Why? Because their number of atoms are same. And 3 mole oxygen. So now we have to find out in terms of 0.5 mole. So you can answer this very easily. So in terms of 0.5 mole of Na2CO3, we have 2 mole of sodium here in terms of 1 mole. So 0.5 mole means in terms of sodium we can say 2 into 0.5, which is 1 mole sodium. Clear? How many mole? 1 mole. Next, carbon is 1 mole in 1 mole of Na2CO3. So 0.5 mole of Na2CO3 has 0.5 mole carbon. 0.5 mole carbon. Similarly, 1 mole has 3 mole oxygen, so 0.5 mole of Na2CO3 has 0.5 into 3 mole oxygen, so which is 1.5 mole oxygen, and 1.5 is this one. Simple. Makes sense? I think that's it. So this is all about mole and molecular weight, and we can do few more questions. I'm going to design this. Look at here. Simple. Suppose I am saying we have methane molecule. Okay, I am saying 32 gram CH4. So my first question is mole of CH4. Second question, mole of mass. Let's do the mass of hydrogen and mass of carbon. So look at here. So 32 gram CH4. So first find out its molecular weight, which is what? 12 plus 4, which is 16. So mole is what? Mole is equal to weight upon molecular weight. Weight is how much? 32. Molecular weight is 16. So how much? 2 mole. How much? 2 mole. So now we have 2 mole CH4. So mole of CH4 is 2 mole. Now how can we correlate the information? Look at here. Whenever you have to find out these things, just compare with 1 mole. So 1 mole CH4 So look at, in terms of 1 mole, we have 1 mole of carbon, 1 mole carbon and 4 mole hydrogen. But we have here 2 mole. We got 2 mole. So number of carbon in 2 mole multiplied by 2. So for 2, it will be 2 mole carbon, 2 mole carbon and 8 mole hydrogen, 8 mole hydrogen. So once you have a mole of carbon and hydrogen, then mass is quite simple. What? The mole is equal to weight upon molecular weight. So mole is here, hydrogen is how much? 8 mole. Weight is x, molecular weight of hydrogen is 1, so 8 gram. And similarly carbon is what? Weight upon molecular weight, x. Mole is how much? 2. Molecular weight is 12, so 24 gram. Clear? So this is all about the mole and molecular weight. If you still have any doubt, you can write down on a comment box. But I think I did my best. So please watch this video and please like the video as well. It can give me an idea like what I am doing. So in the next session, we will discuss molecular formula and empirical formula. We will do a lot of questions based on each and every topic, which can help you a lot. Thank you so much for watching this.